Okay, so the last part of learning objective one here, we've just figured out how do I convert the nominal interest rate into a real interest rate. And we learned a little bit about how those work in terms of calculating how much I'm going to owe when I take out a loan. Okay, now why do we go through the trouble of understanding this Fisher equation and the more complicated version of calculating the real interest rate? Well, when I make decisions, what really matters to me is the real interest rate. Now let's think about why that is true exactly. So when we borrow, what we're effectively doing is we're making a trade-off or a decision between consuming something today and consuming something in the future. So borrowing means trading off consumption today. That's what I get when I borrow versus consumption in the future. Right? So one way that I could attack purchasing a car rather than paying interest on a loan, I could save money for, let's say, 5 years. So I could take the amount of money that I would have paid on my car loan and I could save that amount of money every month for 5 years, and I would have enough accumulated to buy the $20,000 car. So at the end of 5 years, I could buy the car and not pay any interest on the loan, directly at least, right? So why do we actually take out car loans? Is because by saving that money today, I give up some consumption. And given that we're also a little bit impatient, I tend to want the car now rather than in the future. It means we're willing to borrow, which means I'm willing to get something today and give up something in the future when I pay back the loan. Now, what we pay back in the future is the $21,000. So I have to give up $21,000 of consumption in the future in order to get $20,000 worth of consumption today. But what we really care about is not the dollar amount. What we really care about is how many goods and services I'm giving up by paying interest. So let me just do a really simple example here. It's similar to what we did in this past one, only I'm going to put things in terms of goods and services. So let's just assume that there's one good, pizza. So that's the only thing I buy. So when I borrow $20,000, and let's say the price today is $5 per pizza. So when I borrow $20,000, that's going to buy me 4,000 pizzas. So that's what I get today. So I'm going to get 4,000 pizzas today as the result of borrowing $20,000, given the price of pizza. Now, I'm going to have to pay this back in the future. So I'm out $21,000 in 1 year. That's what I have to pay. And so the question is, how much pizza do I give up by paying that back? I know how much I got today, 4,000 pizzas. But how many pizzas do I give up if I pay 21,000? Well, if we stick with the inflation of 10%, that would imply the price of pizza in 1 year would be equal to $5.50. That would be a 10% increase in the price of pizza. So now a pizza costs $5.50. And so what I'm concerned with is how many pizzas am I giving up by paying back the 21,000? And so what I need to do is I need to figure out how many pizzas that is. What's 21,000 over 550? And if we round that, that turns out to be 3,818 pizzas that I'm giving up in the future in order to get 4,000 pizzas today, hence that negative real interest rate. Right? The nominal interest rate is a positive 5%, but I only give up 3,818 pizzas to get 4,000 pizzas. So that real interest rate, another way to think of it, is in terms of pizzas. So if I take the pizza interest rate here you'll notice that works out to be the minus 4.5% or minus 4.55%. Just what we thought. Now, so that's what I ultimately care about, right? Is how many pizzas do I give up by taking out the loan today? So you had to make this decision if you took out a student loan. Take out a student loan for a certain amount of money. You're getting something today, some consumption, and you're going to have to give that up in the future when you pay it back. But what you really care about is how many pizzas you give up by making those payments in the future, not the specific dollar amount. Now, it doesn't always have to be negative. So if, the price of pizza in 1 year is still equal to $5, then the real interest rate is going to be 5%. I'm going to give up 5% of my pizzas in the future as a result of this. So that's 4,200 pizzas that I give up in the future if the price didn't change at all with no inflation. And so the real interest rate in that case is exactly equal to the nominal interest rate, just what our Fisher equation would tell us. 200 over 4,000 is our 5%. So when the inflation rate is 0, the real and nominal interest rates match up, and you have anywhere in between there. So that's a very brief primer on interest rates, real interest rates, and specifically why we care about real interest rates and not nominal interest rates. So you're going to have to practice with that a little while to get the full intuition. And to kind of help with that, I've got a couple simple questions on Learning Objective 1 on Canvas. Give those a shot. The solution is posted there as well. And keep going back over this until some of that makes a little bit more sense.